In this video, we are going to solve our paper Physics Pearson Edexcel International GCSE 912 PR. Okay, it is a regional paper, 2 PR over there. 1 hour 15 minutes is required time for this. It is 70 marks paper over there. It is 70 marks paper. All right. Before the start of solution, I will say kindly subscribe my channel and share the video and subscribe the channel over there and like the video. And if you have any question related to this video or this paper, kindly comment on the video. I will try to respond as early as possible over there. Let's start to the solution of this paper over there. Some questions must be answered with the multiple choice questions over there. Okay, a flour mill is a factory where flour is produced. The photograph shows some flour moving through metal channel in the flour mill. Over there, flour is shown and metal channels are shown over there. The flour particles can become charged as they move through the metal channels over there. Explain how the flour particles can become charged over there. So I can say here that as the flour particles move and rub against the metal channels, friction occurs over there. I can also write over there, no problem for it. I say the floor, as the floor particles move uh, and rub against the metal surface and rub against the metal surface, the friction occurs over there. Friction occurs. So I can say here that this friction causes the electrons to be transferred from one metal to other. This friction causes the electrons to move from one metal surface to other, and static electricity is being caused over there, and the particles becomes charged because they gain an imbalance of an electron over there, and metal surface gets charged, surface gets charged as they get imbalance of electrons, as they get imbalance of electrons from neutral to charge, like positive and negative. Like they are moving away, then positive charge is behind it, and negative charge where they are being attained over there. Okay, now he is going towards complete the passage over there. All right, some fill in the blanks are given you for 2 marks over there. Here he is saying move by writing a suitable word in each blank space. Okay. Floor particles move away from each other because they have, we can say, because they have the same charges, and this causes the floor particles to exert repulsive forces on each other over there. Now he is saying the dust created by producing a floor in a floor mills is dangerous because the dust is flammable. This creates a risk of explosion. Explain why connecting the metal channels to earth reduces the risk of an explosion in floor mill over there. So I can say like charges repel each other. And no, that is done for the previous one over there. So here we can say that connecting the metal channels, connecting the metal channels to earth channels, metal channels to earth to earth provides a low resistance path, a low resistance path uh, for the charge to flow, for the charge to flow, for the charge to flow to the ground, to the ground, and this prevents this prevents the build up of static charge um, on the metal channels, on the metal channels on the metal channels, and the floor dust, and the floor dust over there. Since dust, I can say here, since s- a spark requires a spark requires a high charge concentration, a high charge concentration over there, for which we can say earthing eliminates the source of ignition. So earthing eliminates the source of ignition. So I think so. If you read it again, then you can easily understand what I want to say over there. Just take a screenshot and read it between the lines over there. Okay. Uranium-239 is an isotope of an element uranium. State what is meant by the term isotope. Atoms of an element, atoms of an element which have same atomic number, or you can say proton number, and different atomic mass means neutron number is different for adding with proton. Also different atomic mass um, are called isotopes of that atom over there. Uranium-235 can be represented by using symbol 92 and 239. Protons are one type of particle found in the nucleus of an atom. How many protons in the nucleus of an atom of uranium-239? So remember that protons are giving us the proton number by atomic number over there. So it will be 92 over there. This is the proton number according to atomic number will be given over there. And remember that the symbol is this. This is your Z, this is your atomic mass, and Z is proton number. Give the name of other particles found in the nucleus of an atom of uranium-239. That will be neutron over there. We know in the nucleus proton and neutron are present over there. Okay, here he is saying that 239 is a radioactive and decays by beta emission over there. Uranium has half-life of 23 minutes. A sample of uranium has initiated 60 gram mass over there. Then how much mass will be remaining after 46 minutes? So it means two half-lives are taken over there. Then I will say in 60 gram is at its initial state is divided into 30 gram after 23 minutes. And in the next 23 minutes for 46 making, it is remaining the mass of 15 gram over there will be present to be taken, that it is the pending mass over there. After that, he is asking there, when uranium 239 undergoes a beta decay, an isotope of an element, neptunium Np is produced. Which of these is the correct symbol of the neptunium produced in the beta decay of uranium? Then remember that when beta decay is happening, mass will stay as it is, but atomic or proton number is going to increase by 1 over there. So 92 and 239 means it is 92, Neptune 92 and 239. 92 will be added plus 1 over there, so it should be option C will be fine for it. You will attempt this like this and this to shade, okay, not to circle like me over there. I'm just highlighting this, that mass number is staying same over there and beta decay is happening over there and atomic number is increased by 1 over there. Okay, mass number stays the same, remember that, and atomic number is increased by 1 over there. After that, he is saying for next question over there, he is saying the photograph shows the tidal power station across estuary of the river Rennes in France. Okay, the diagram shows a simplified view of tidal power station. The river is there, sea is there, water at low tide and water trapped at high tide over there. So a tidal barrier is present and a turbine shaft is existing over there. So this question is related to tidal power over there. Okay, at high tide, water is trapped behind the tidal barrier. Okay, at low tide, the trapped water is released through the turbine shaft. This causes the turbine to spin and which generates the electricity over there. Give two advantages of generating electricity by tidal power over there. Then I will say that it is renewable. It is a renewable energy source, and it will not run out. And on the other hand, it will say it does not produce any, it does not produce any type of greenhouse gases or global warming, like that, greenhouse gases over there. So tidal power is having these two benefits over there. After that, he is saying give two disadvantages of generating electricity using this. So I will say that it can have it can have a negative impact, and it can have a negative impact on local ecosystem or wildlife, on wildlife over there. And I will also say the initial cost is very high. Is very high over there. Initial cost to start the project over there in the ocean or sea over there will be taken very high over there. All right, let's go for next one here. Here he is saying that at low tide, water flows through the turbine shaft. Okay, at the height, trapped water in the river decreases. Water falls through a height of 8 meter. Okay, this is the height. That is 8 meter. Calculate the energy of the gravitational force in 1 kg of water flows through the turbine shaft using this formula. So change in energy, potential energy will equal to mass. He said 1 g is 10 and height is 8. So we can say it is 80 joules is the change in its energy over there. Energy transferred will be 80 joules over there. The tidal power station has a maximum output power of 240,000 kilowatt when water falls through a height of 8 meter. Calculate the mass of water through the turbine which is being taken over there. So I will say per kg which I have calculated is 80. So the mass will be going to be divided over there. So I will say here that maximum power is given and I have to calculate the mass. So per kg energy transferred is given in 1 second is being taken. So I will say power is equal to mgh over t, and t is 1 second and power is also given. I have to calculate the mass over there. Mass is equal to uh, power multiply time over g multiply h. So power is 240 with 1 2 3 zeros, and also kilo also having 1 2 3 zeros, divided by g is 10 and 8 is height over there. 1 0 is gone with 1 0. 80 8 3 the 24, 1 2 3 4 5 6, 2 3 4 5 6 zeros are being converted to show the mass is 3 with 6 zeros. 3 1 2 3 4 5 and 6 zeros kg is the mass of the water which is transferring this power over there. Okay, the question is about transformer. Describe the structure of step up transformer over there. So I am making an iron core, along which I am saying here that there are a number of turns showing the input step up. I'm showing only the 2 turns there, and here I'm showing the 1 2 3 4 turns. This is NB and this is NS, number of turns of primary coil and number of turns of secondary coil. In step up transformer, remember that number of turns of secondary coil will be number of greater than number of turns of primary coil over there, and it will be having a soft iron core here. That is soft iron core that is present over there, and it has more turns on the secondary than on primary, and soft iron core links the magnetic fields to of the two coils over there. So step up transformer is much clarified for you, where you can say the transformer in which number of turns of secondary coil is greater than number of primary coils. And for example, if I'm giving here 10 volt as input voltage, it will be converted into 100 volts, means voltage is step up by this phenomenon over there. Now he is saying a step up transformer has an input of 230 volt and input current is 4.5 ampere. The output current of the transformer is 0.21 ampere. State the formula linking the input power and output power. Then across primary is input VPIP is equal to Vs multiply Is also over there. Calculate the output voltage by using this relation, just putting the values over there. Vp for 230 and 4.5, 30 multiply 4.5 is equal to IS is 0.21 multiply Vs. So just by arranging 230 multiply 4.5 divided by 0.21, I can calculate here my secondary voltage. If you just put this into your calculator, you will get the voltage that will equal to approximately equal to 4928.57, and if you write it approximately equal to 4930 volt will be the output voltage across the secondary coil over there. Let's move to the next question over there. What he is asking over there. Uh, a tennis ball is dropped from the height above the ground. All right, diagram shows a tennis ball at an instant when it is released. On the diagram 1, draw the label the arrow to show the forces acting on the tennis ball at the instant it is released over there. So I will say a single downward pointing arrow for the center of the ball labeled as weight or gravity will be drawn over there. That weight is acting this ball to act downward over there. Okay, that's I think so. That's for only 1 mark over there. And later on, I will also say that upthrust is going to act over there. Now he is saying diagram 2 shows that the ball is an instant when it hits the ground over there. Tennis ball is hitting the ground. Okay, just before hitting the ground, the tennis ball is moving downward at a velocity of 2.5 meter per second. And just after hitting the ground, the tennis ball is moving upward with the speed 1.9 meter per second. The mass of tennis ball is given this. Calculate the change in momentum. Remember that both momentum should be added over there, but the direction will be opposite over there. Okay, then I will say m is taken as 0.057 into v plus u, because the when direction change is happening over there, and this change in momentum will be taken as negative because momentum is also a vector quantity over there. 2.5 plus 1.9, and if I do this 9 5 14, 1 carry, 1 2 3, 3 and 1, 4.4 into 0.057, and this negative, I said there is a change in momentum and change in direction is being taken over there. And if you are going to multiply this with this 4.4, then you are getting 0.2508, that will be kilogram meter per second as a unit of momentum over there, or Newton second also being taken. So you can write it minus 0.2508 with unit kilogram meter per second, or you can also write Newton second over there as a unit in the case of momentum. The ball is in contact with the ground for a time of 6 milliseconds. Calculate the force. So F is equal to mv minus mu over t over there. So change in momentum I have calculated, that is 0.2508 divided by 6 milliseconds. 6 multiplied 10 raised to power minus 3. And if I go with this to be dividing over there, then I will get my answer as 41.8 Newton. And remember that he also said give the direction, and direction will be upward direction over there should be added, because I can say the ball's momentum change was large vector pointing upward with the much more positive value, and the force caused during the change must also act upward over there. Okay, let's move to the next part here. The coefficient of restitution can be used to determine how high the ball will bounce. The higher the value of coefficient of restitution, the higher the ball will bounce. Diagram 3 shows the ball being dropped from a height h1 over there above the ground, okay, and the ball hits the ground and bounces at the top of bounce, reaches the height h2, okay, means the ball is dropped position over here, it is hitting over here, and it is bouncing back with the height h2 and falling with the height of h1 over there. Now what E is asking for, the coefficient of restitution can be given according to this relation. A student decides to investigation to compare the coefficient of restitution for different types of balls, design a method, variables of investigation, and how to obtain the accurate measurements, how to obtain the reliable results. You may add diagram 3 over there in your answer. So here I will say that first of all, I will go with independent variables like type of ball, tennis ball, basketball, or ping pong ball, like that I can take. So I will say the variables which I will take first, variables which I will take here. I will say that these will be independent variables, independent variables which can be taken as independent variables should be taken as type of balls over there, type of ball. And here I said I am taking three types of balls: tennis ball, I am taking basketball, I am taking ping pong ball over there. And for dependent variable coefficient of restitution, like calculated from h1 and h2, independent, and that will be dependent variable there, that will be calculated from height h1 and h2 as coefficient of restitution over there, coefficient of restitution over there. And for the control variables, I will say height from which ball is dropped, like h1, the same hard surface, same miring apparatus, and ball released from rest over there. That will be the control variables for this section over there. And accurate measurement can be measured by using a meter rule or a tape measure fixed vertically next to drop zone, and use a camera with a slow motion high speed recording features to accurately capture the maximum bounce height of h2 over there. If we observe like that, okay, easily can be measured by using a digital slow motion camera over there. Pause the video at the top of the bounce and alternately use a marker like a cardboard that can be moved up and down next to the ruler until it aligns with the top of bounce over there. And repeat the experiment for each type of the ball at least 3 times and calculate the mean of height h2 for each ball before calculating the coefficient of restitution. This reduces the effect of random errors and anomalous values over there. This will be your whole method. If you have got this, then it's fine. Otherwise, take the video 1 minute back and try to listen and start writing on your register by noting down all the values which I have tried to explain for this question over there. This question is about cosmic microwave background radiations and Big Bang. Okay. Cosmic microwave background radiation CMBR is has a mean frequency of 1.610 raised to power 11. State the formula linking the speed, frequency, and wavelength, that is V is equal to F lambda over there, where F is frequency, lambda is wavelength, and V is wave speed over there. And after that, what he is saying in the next part, show that the mean wavelength of CMBR is 2 millimeter. Speed of light is being taken. So make this lambda as a subject, V over F, and V is 3 multiplied 10 is to power 8, and F is 1.6 multiply 10 raised to power 11, and 1.6 and 30, it is approximately equal to 2. 1.6 or 1.5 dividing by 3 is approximately 2, and 10 raised to power 8 and 10 raised to power 11 giving 10 raised to power minus 3. 2 multiply 10 raised to power minus 3, which is approximately equal to 2 millimeter as the wavelength of this section over there. CMBR was first released from the after the Big Bang over there. So he is saying when CMBR uh, released, it had a wavelength of 9 multiplied 10 to the power minus 5 millimeter, but now it has the wavelength of 2 millimeter. Use your information, explain how CMBR supports the Big Bang theory over there. So for this one, I will say the Big Bang theory predicts that the early universe was extremely hot and dense, and CMBR is the red-shifted remnant of these thermal radiations released when the universe cooled enough for atoms to form, and we can say and became transparent. And the fact that we can detect this radiation uniformly from all directions is strong evidence for this initial hot dense state over there. Okay, this was the explanation related to Big Bang theory over there. Okay, now he is saying explain how cosmological redshift of galaxy also supports the Big Bang theory over there. So I will say here, okay, I write down here because it is for 4 marks and I will have to add at least 4 reasons over there. So I will say light from distant objects, distant galaxies is observed to be redshifted, observed to be red shifted over there. And we can also say that the red shift is red shift is basically related to due to is due to Doppler effect. Doppler's effect, which we can say, which tells us that, which tells us that uh, we can say these galaxies are that these galaxies are moving away from us. So it is explaining the Big Bang theory. And the further away a galaxy, the greater the redshift, meaning it is receding faster. So it is receding faster over there. And so here we can say this observation of expanding universe is exactly what the Big Bang theory predicts. So if the universe is expanding, it must have been much smaller, hotter, and denser in the past over there. Okay, let's move to next question over there. What he is asking here. Okay, the photograph shows a cup designed to keep the drink hot. Okay, thermal physics. Shiny silver colored surface inside and plastic lid at the top. The inside surface of the cup is shiny. Explain how the shiny silver colored surface helps to keep the drink hot over there. We know that the shiny surface is a poor emitter of infrared radiations since heat loss by radiation is reduced and the drink cools slowly. Okay, I write it also for you. Just note down if you are not getting what I want to say over there. The shiny surface is poor emitter, of infrared radiations over there. Since heat loss by radiation, since since heat loss by radiations over there uh, is reduced, so the drink cools down more slowly. The drink cools down more slowly over there. So we can say for the next part over here that explain why a drink in the cup will stay hot for longer when the lid is placed on the cup over there. So according to this, when he is saying lid is placed above it, I will say the lid prevents uh, heat loss by evaporation over there, because high kinetic energy molecules are leaving the surface. So by trapping water vapors over there, and by convection also towards the surface, by preventing the hot air from rising away from the liquid surface, the lid is stopping the drink will stay hot for longer time over there. He is stopping the evaporation, and also stopping the hot air to escape from the surface of your liquid over there. Here he is saying a student investigate how the temperature of the drink of a cup varies with time. The student's method pour some water into the cup and placed the lid on the cup. Wait for the water to cool down 80 degrees centigrade and then starts a stopwatch. Measure the temperature of water in a cup of every 10 minutes. So he is showing 0 to 50, 100, and his relation is shown over there, that temperature and time. Like when time is increasing, the temperature is decreasing over there. So what he is asking in the relation of graph relating information over there. On the grid, draw a tangent to the curve when the temperature is 40 degrees centigrade over there. So I will say a straight line that just touches the curve at 40 degrees centigrade, matching the slope of the curve at that point over there will be being taken. So 40 degrees centigrade is the this point. So then if I want to draw a tangent over here, it will be drawn like this. Okay, it is just like a straight line that touches the curve at 40 degrees centigrade, matching the slope of the curve at the point over there. So this was my tangent to be drawn. Now he is saying calculate the gradient of the tangent to find the rate of temperature change of water when it was 40 degrees centigrade over there. Okay, then I will say that the temperature during which it is changing from its value, like if I am increasing it more like this, and if I am taking it to my temperature like here to here, I'm taking the second point here. Okay, and for this one I will have to take my time, as um if I make more straight, more precise on the paper, then I will take this value over there. Then by using these 2 points, this point is having a 60, 70, 70, 0, and this point is having the vertices. Let's suppose it is 175 and 160. Let's 165, 165 comma 20, 30 degrees centigrade. Then go for gradient calculation. M is equal to y2 minus y1 over x2 minus x1. Then you can use this formula for calculation of your rate to be calculated. So if you go for its calculation, then I will say 70 minus 30 is 40, and 0 to 165. So it is 4 over 2 over 70, 40 over 165, and it is with the negative temperature coefficient, and it will be approximately 0.2 to 0.3 degrees centigrade per minute will be your rate of change for this question over there. Now let's look what he is asking in the rate of change. By the okay, a student is working in the laboratory at room temperature of 20 degrees. Draw a line on the graph to show how the temperature of the water in the cup would change if there was no lid on the cup over there. So a curve starting at 80 degrees centigrade will be taken. The initially falls starting this that initially falls more steeply than the original one, like this one, because the lid is not present over there. And then I will say here, then the original curve and levels at the room temperature of 20 degrees centigrade, reaching 20 degrees centigrade more sooner over there, like this, more sooner because the lid is not present over there than the original curve, and then showing this straight line curve. I have taken for 20 degrees centigrade to reach over there. Okay. Let's move to the last question of this paper over there. That is question number 8. A high frequency sound wave is detected by a microphone and displayed on the oscilloscope, on an oscilloscope over there. The diagram shows the oscilloscope screen. When sound wave is detected, it also shows an oscilloscope setting over there. Give the maximum frequency of the sound can be heard by humans, that is 20,000 hertz, or can also be written as 20 kilohertz over there. That is the maximum frequency which a human can hear over there. Determine if the sound wave is displayed on the oscilloscope could be heard by humans. Then I will say here that determine if the sound wave displayed on oscilloscope could be heard by humans. So first of all, I will have to go for time period to calculate over there. So I know the relation F is equal to 1 over T. So T is equal to 1 over F to be taken over there. So the value which he has given here to me in X direction as a time period. So that is from this point to this point, he said y direction 1 square 10 millivolt, and axis direction 20 microseconds. So it is 20, 40, 60, and 80. So it is 80 milliseconds is the time period over there. So I can say here F is equal to 1 over T is equal to 1 over 80 multiplied 10 raised to the power minus 6. And if I go for its calculation over there, then it is giving me the frequency value as 12500 hertz over there as its frequency. So 12,500 lies inside the human frequency range, because the human frequency range is 20 to 20,000 hertz over there. So therefore we can say yes, this sound wave could be heard by humans over there. Here he is saying a student changes the setting of the oscilloscope to alter the display wave in these ways. Increase the amplitude of wave, only displays the time period on the wave on the screen. The table shows the possible. Okay. Which row of table gives the students new oscilloscope setting over there? Increase the amplitude and increase the amplitude, only display the period. So display period is like to be increased and y direction, and amplitude should be increased over there. So option C will be perfect for this answer over there. Why I am saying a C over there? Because the increase in amplitude on the display, you need less sensitivity on the y-axis. So it will be 5R like that. And sensitivity on the y-axis to, so each square represents a large voltage, and changing 10 millivolt to 5 millivolt square along y direction will be much more suitable. So 20 are gone, and when I am looking towards my x direction for time period per square meter over there, then I will say you need to go for 20 millivolt square to make a wave take up fewer squares and appear smaller in amplitude over there. And where the question says increase in amplitude of the wave on the display to make more trace to make the trace taller over there, taller, and you need more sensitivity and fewer millivolt per square meter. So 5 millivolt per division would make the amplitude appear larger, and to display one time period on the screen you need a faster time base, less time per division. So the original period was 80, so I will not have to take much larger, but here I will say that which took 4 squares to fit according to the above figure. If you look above there, that it takes the 4 squares over there. So I will say the original time period is 80 microsecond, which takes 4 squares, and to fit one period across the more squares for easier viewing, you need a slower time base, more time per division. So I will say 40 microsecond per division should be is slower than 20 microsecond over there. So you should go for 40 to divide by 5 millivolt, and row number C will be fine for it. So it should be 40 to be taken over there. This was your whole paper. This was not done with the help of marking schema like that. I tried to explain in my own words. And if you feel that according to the comparison of marking scheme, something is going to not be more precise and accurate or like that, then remember that I am just delivering these paper solutions on the behalf of my knowledge. And I tried to give you the best idea of that question. How can you summarize in a best way? Thank you so much for today paper. In the next paper, you will watch towards chemistry and biology and mathematics also over there. Kindly subscribe my channel and share the video with your friends. Thank you so much.